Recent research suggests that antibiotic use during infancy may be associated with a higher risk of weight gain later in childhood. While antibiotics are essential and often life-saving medications, scientists are increasingly studying how early exposure may influence long-term metabolic health. The first years of life represent a critical window for development. During this time, the gut microbiome, the complex ecosystem of trillions of microorganisms living in the digestive tract, is still forming. These microbes play an important role in digestion, immune system development, and metabolic regulation. When antibiotics are prescribed in infancy, they do what they are designed to do: eliminate harmful bacteria. However, they can also affect beneficial microbes that are part of the developing gut ecosystem. Researchers are investigating whether these early disruptions may influence how the body regulates weight later in life. Large observational studies have found that children exposed to antibiotics during their first 1 to 2 years may have a slightly higher body mass index, or BMI, as they grow older. Some studies suggest that repeated courses of antibiotics may be associated with a greater likelihood of overweight or obesity in later childhood. It is important to emphasize that these findings show associations, not proof of cause and effect. Many factors influence a child's growth trajectory. Genetics, diet, physical activity, socioeconomic factors, and the underlying infections that required antibiotics in the first place may all play a role. Researchers believe one possible explanation involves changes in the gut microbiome. Early microbial communities help regulate energy extraction from food and influence metabolic signaling pathways. If certain microbial species are reduced or altered during critical developmental windows, this could theoretically shift how efficiently calories are processed or stored. Animal studies have shown that early antibiotic exposure can lead to increased fat mass in some models. In humans, the effect size appears modest, but consistent patterns across multiple studies have drawn scientific attention. Another important consideration is the timing and frequency of antibiotic exposure. Some evidence suggests that exposure during the first 6 months of life may have a stronger association. Compared with exposure at older ages, repeated antibiotic courses may also amplify the effect. However, antibiotics remain vital tools in pediatric medicine. Bacterial infections can be serious and even life-threatening. The goal of this research is not to discourage appropriate antibiotic use, but rather to support careful prescribing practices. Clinicians are increasingly aware of antimicrobial stewardship, the principle of prescribing antibiotics only when clearly indicated, and selecting the narrowest effective spectrum when possible. This approach helps reduce antibiotic resistance and may also minimize unintended effects on the microbiome. Parents may wonder what this means in practical terms. The key takeaway is balance. If a child has a confirmed bacterial infection, antibiotics are often necessary. At the same time, unnecessary antibiotic use for viral illnesses should be avoided, as antibiotics do not treat viruses. Supporting a healthy gut microbiome after antibiotic exposure may also be helpful. Breastfeeding, fiber-rich diets as children grow older, and diverse whole foods can contribute. Research into probiotics and microbiome restoration strategies is ongoing, but no single solution has been definitively established. The broader scientific question remains: does early antibiotic exposure permanently alter metabolic programming, or are these changes reversible over time? Some studies suggest that the microbiome can recover, while others indicate that certain shifts may persist for years. As research evolves, scientists are working to understand which children may be more susceptible to long-term effects and how environmental factors interact. For now, the message is measured and evidence-based. Antibiotics are essential medications when used appropriately. At the same time, early life development plays a role. Understanding this balance allows healthcare providers and parents to make informed decisions grounded in science rather than fear. For more science-based health content, follow HealTalk.org.